And for number 53, where is it increasing, decreasing, concave up, concave down, minimums, maximums? In other words, find everything out about it. So for this part, we need the derivative. And for concave up and concave down, we'll need the second derivative. So first of all, the first derivative. The derivative of a natural log function is 1 divided by what's ever in the parentheses. And then you need to do the chain rule. So take the derivative of the inside, and that's going to be 4x cubed. Now we need to find the critical values. Since this is a fraction, we could actually break this into two problems. One would be, when does the derivative equal 0? And when is the derivative does not exist? So this one comes from when the numerator equals 0. And this one comes from when the denominator equals 0. So with this one, you can divide by 4 on both sides. It'll still equal 0. You could take the cube root, it still equals 0. So as far as the first derivative equaling 0, there's just one answer. Then what about where it does not exist? Well, if you subtract 8 from both sides, it would look like this. And then if you try to take the fourth root of a negative number, that is an imaginary number. And all throughout Math 3A, 3B, and 3C, we don't use imaginary numbers. So that one's out. So the only one that we get is 0. So let's now take a look and see what's happening at 0. So the function, the natural log of x to the fourth plus 8. And then if you take a look at the graph, it just has this one minimum value right here. So if you find out when x equals 0, so that's going to be the minimum. So when x equals 0, y is a 2.079. And then as you can see, the left side is decreasing and the right side is increasing. So for decreasing, that would be from negative infinity until you get to 0. And for increasing, that would be the right side. So from 0 to infinity. Now we're done with the first derivative. Now it's time to move on to the second derivative. And that might require a new piece of paper. So first of all, I'm going to write down that the derivative equals 4x cubed over x to the fourth plus 8. And then we'll need to find the derivative of the derivative. So in order to find the second derivative, we need to use the quotient rule. So that starts with the derivative of the top, which would be 12x squared, and then times the x to the fourth plus 8 left alone, and then minus, you leave the 4x cubed alone, and then take the derivative of the bottom, which is going to be 4x cubed. The last part of the quotient rule is that x to the fourth plus 8 gets squared. Notice that this x to the fourth plus 8 and this x to the fourth plus 8 cannot cancel, because if you're going to cancel, it would have to show up in that term also. So it would have to show up in all three terms if you're going to cancel it. And it doesn't, so we can't cancel. And just like with the last one, you can take the top and set it equal to 0. You could take the bottom and set it equal to 0. Although, I just did this one a moment ago and it gave me an imaginary number, so that's not going to give us any solutions. The only solutions are going to come from when the top equals 0. Now what to do with the top? Well, we could factor out a 4 from both of these, and we could also factor out an x squared. So factor out a 4 and an x squared, and then what remains? So if you factor out the x squared, that's gone. If you factor out a 4, it leaves a 3. So then distribute that 3, there will be 3x to the 4th, and then that 3 times 8 is 24. Now this 4 got factored out, and 2 of the x's got factored out, but there's still a single x. So that means that there's a single x times this, so it's going to be 4x to the 4, and then don't forget the minus sign. Inside the brackets, you can combine like terms, so these two would combine to just be a negative x to the 4th plus 24. And now that it's factored, you can set each factor equal to 0. So 4x squared equals 0, or negative x to the 4th plus 24 equals 0. With this one, you could divide by 4, so that leaves you with a 0. You could take the square root, and x equals 0 is going to be one of the important numbers. And for this one, you could add x to the 4th to both sides. It'll become positive. And then take the 4th root of both sides. And when you do, it's going to be plus or minus the 4th root of 24. So for the 4th root, you could go to math and then the x root and put the 4th root of 24. Another way to do it is you could say 24 is raised to the 1/4 power. And either way you do it, you get plus or minus a 2.213. So you get a total of 3 important points. And then take a look at the graph and see what's going on. So if you look at this middle part, so about that middle part, so that's concave up. This part is concave down, and this part is also concave down. So the trace 2.213, so that's the dividing point, or it's also called the inflection point, where it changes from being concave up to concave down. And negative 2.213 on the other side. And then 0, well, it doesn't look like it changes concavity at 0. So it's just, that's just an extra point that we don't actually need. So let's see, this is, so I'm going to label concave down first of all. So that would be this left side, which would go from negative infinity to this negative 2.213. 2.213. And then this side is also concave down. So that's going to go from 2.213 to infinity. And then for concave up, that would be the middle part between negative 2.213 and 2.213 is concave up. One last thing I forgot is there's the minimum point right there. Oh no, I got that. Sorry. It's all good. Excellent.